Alright, let's compare the steel design with the manual calculation and what can we obtain from STAAD Pro. The reason why I upload this video is only because my teacher, the structural engineering teacher, told me that hey Regin, do you know that the results obtained from the software cannot be reliable? That shows some error with the manual calculation. So I just only want to compare the manual calculation and what we have obtained from STAAD Pro. So right now there is a steel design which is seen in front of me, and I'll compare the results with what we can obtain from STAAD Pro. So let's start it. These and all are the combinations which we don't want to see that. I'm not going for any sort of combination. First we have to find out the epsilon. For the detailed calculation on what and all are these, I had already uploaded a video for steel design which we compared in tabs. It's the same problem. Alright, okay, intention is just to design a column here. So first let's get into the STAAD Pro. Alright, so let's get into here. I'll be picking up a metric units analytical model and just create a new model here. Alright, as from the question it's clear that clear that the height of the column is 3 meters. So let's get into here, grid, being grid. So this one goes 3 meters high, so let's stay there. And next let's get into the property. The properties are elastic modulus is 200 into 10 raised to 3 megapascal. Right now the unit system metric system is kilonewton and meter, so I just wanted to change my unit. So this one can be Newton mm, so Newton and millimeter. Alright, apply that. Next I can get into the materials. I like to create a new material right in here. So create, the material should start from steel, but it's not steel. So steel 200 into 10 raised to 3 megapascal. As you know that megapascal is same as that of Newton per mm square. Poisson's ratio, everything else is correct except the shear modulus. It is 76923, 769 and 23 is there. Alright, okay. Now, alright, from here, starting from steel, the yield stress is given to be 250, and the other strength is TR. What's the spelling? I'm sorry, STAAD Pro. Anyone watching from Bentley? I see that the tensile strength, the strength is spelled wrong, but anyway, I got it. That is 410 as per the question. You can see right in here. Alright, I got a material. Now let's assign a property. If it's from section database, come on, did I press it? Yeah. Right in here I can go for indent section. ISMB 350. As you can see, the section is ISMB 350. Right in here, ISMB 350. The material is steel. Add it and close it, and also you can just assign it right here. Okay, that's it. Now I'm gonna go for node cursor to assign a support here. It's kind of clear to me that support is pin support, so I can anyway get into here and create pin support here and assign it right there. Alright, now let's talk about the load, which is only a 1 kilonewton load. Right in here, get into loading, load case details and add it. I'm not carrying any load combination, so leaving that part blank. There is no self weight. Anyway, nodal load is minus 1 kilonewton as the load is 1000. I'm kind of ignoring that. And assign, use cursor to assign, then just write in here, okay? I'm not caring about the scale or anything anyways. The load value is 1 into 10 raised to 3 Newton, that's it. Well, then I can make an operand right there, then run the analysis. Yep, save it. So right now, this analysis result brings me nothing. Let's get into the steel design. Before getting to steel design, I'm gonna switch back my units to Newton mm. It's not compulsory, but let me try that. Yeah, getting to steel right there. The real code, that is IS 800 2007 LSD. This one is the code that belongs to 1984, which is not at all relevant right now. So I'm gonna turn back my code into IS 800. The only one parameter that I would like to pick is track. Everything else is, I don't care. We don't want anything more, so let's define the track. Before that, I would like to select the member. So track brings the enhancement in the result printing. So that's it. Now writing commands, I'm just only assigning the code, and member takeoff is not required. Also optimization is also not required, because right in this problem we will be finding out everything that's related, whether the section is plastic or flange compression, which one is the buckling class. We'll be finding out buckling class. Finally, we'll be finding out the allowable stress. The applied load is 1 kilonewton, and the allowable stress that it can withstand, or allowable force that it can withstand, is only 734 kilonewtons. So let's see if we can attain that. We don't want to change any section here. That's all right in here. Just run the analysis and I can get into the output file. Still design here. I just only wanted to check whether the force is 734 here. Yeah, that is 734. Where is the 734 here? This is 734. So both matches together, and which proves that what हमने जो सही किया है. So this message is to all the old structural engineers who hate computer programming, all these softwares. देखो सॉफ्टवेयर की इस्तेमाल यह है कि हम हमारे काम जो आसानी से कर सकते हैं. आप लोग जो कंप्यूटर से नफरत कर रहे हो तो सही नहीं है. So just get away if you are not going good with computer. That's all. Thank you.